Okay, so in this video, we are going to discuss some NUST entry test sample questions which are related to the topic partial fractions. Okay, but before discussing the questions, we are going to discuss some contents which are important, and then we can talk about the questions. Right. So whenever we talk about partial fractions, we should know that we have two types of partial fractions. Okay, one is proper and the other one is improper. Right. So let's talk about the proper ones first. The partial fractions p of x by q of x, we can also call it partial, okay, because rational already means fraction. So whenever we're talking about polynomials and fractions of polynomials, we call them partial fractions, right? So a proper partial fraction is of this type. Why? Because degree of the numerator is less than the degree of the denominator. Now in partial fractions or rational fractions, whatever you call it, thing is same. You guys need to understand that we are going to have polynomials in numerator and denominator, right? We will be having two expressions of x, one in numerator, the other one in denominator, and we have to talk about the degree of that polynomial in order to understand if it is proper or improper. So if we look at this first example, here in the numerator, we can write x to the 0 because x to the 0 is 1, and we can multiply 1 with any fraction, with any equation, because that does not change anything. So the degree of numerator is 0 and the degree of denominator is 1, right? So this means that since 0 is less than 1, this means that it is a proper fraction, because this is what the definition says. P of x is less than the degree of q of x, right? Let's talk about this third example. Here, the degree of numerator is x square, so it means that the degree is going to be 2. And if we talk about the denominator, we have x cubed minus 3, so degree would be 3. So again, since 2 is less than 3, since degree of numerator is less than the degree of denominator, this means that it is a proper fraction. Now let's talk about improper fractions. Okay, improper rational fraction or improper partial fractions is the same thing, is called if the degree of p of x, that is the function in numerator, is equal to or greater than the degree of q of x. Again, we're talking about partial fractions. We will have a polynomial in numerator, a polynomial in denominator, and we need to talk about the degree, okay? So it is going to be improper if the degree of numerator is equal to the degree of denominator. If we talk about first example, degree of numerator is 1 and degree of denominator is also 1. And why are they 1? Because I have x to the 1 here and x to the 1 here, okay? So this is improper. Even if the degrees are equal, even then that is improper, right? And obviously, if the degree is greater, like here we have 2 and here we have 1, so this certainly would be improper. Okay. And whenever we have improper rational fraction, it can be changed into proper by long division. We'll discuss that later. So far, you guys should only know the difference in proper and improper partial fractions. In proper, the degree of numerator is less than the degree of denominator, and in improper, the degree of numerator is either equal or greater than the degree of denominator. Okay, and just know whenever we have improper fractions, we cannot deal with them directly. So first we use long division, and after long division, we have our improper fraction. So we had improper initially, we use long division, and then we get proper fraction. Okay. And now let's talk about questions. So the very first question is 4 of x equals 5 is or an, okay, conditional equation, identity, equation, or fraction. Now, clearly, it is not a fraction. Let's cut this option. And it is not an identity. Why? Because the left hand side and the right hand side, they are not identical. We have x here, we only have numbers here. So it is not an identity. So either it is a conditional equation or it is equation. Now, certainly, it is an equation. I mean, we have this equality sign. This is telling us that it is an equation, but such type of equations are basically called conditional equations. Okay. So far, like I assume that you guys must be thinking this should have been equation. Yes, it is equation. This is the equation which you guys have been dealing with, but we call it conditional equation. Okay. Right. So let's talk about the second question. X minus 2 into x plus 2 equals x square minus 4 is an, okay. Now what is this? Is it an equation, identity, conditional equation, or fraction? Right. Now if we look at the left hand side particularly, let's do it here. Left hand side is basically x minus 2 and x plus 2. And if we simplify it, we will get x into x, x square minus 2x plus 2x and minus 4. These two can be cancelled and we are left with x square minus 4. Now I have only simplified the left hand side and I got x square minus 4, which basically is the right hand side. This means that this way or the other, left hand side and right hand side are identical. If two sides are identical, this means that it is an identity, right? Okay. Now let's talk about the third question. If p of x cube plus qx square minus ax plus b equals this, then the values of p, q, a, and b are. Okay. Now for such questions, we need to make comparisons, right? And how do we make comparisons? By finding out the same x, right? Now if we have p, with p we have x cube. We need to find the coefficient of x cube on the right hand side, right? So this is the right hand side and this is the left hand side. First, we are interested in finding p. So since p is the coefficient of x cube on left hand side, we need to find the coefficient of x cube on right hand side, that is 2. This means that p is going to be 2. Since we know p is 2, since you're sitting in your NET exam, you don't have that much time, start looking for options from here, okay? So p is 2, so D cannot be the answer, okay? Let's talk about q then. Now here q is the coefficient of x square. So let's look at the coefficient of x square on right hand side. It is minus 3, okay? Q is minus 3 and you have to be extremely careful with the sign. We have plus here. This means that this q has this minus, okay? So this is why we are writing minus 3, okay? Now again, let's look at the options. So A has 2 and 3. This cannot be the answer because we have minus 3. Then again B has 2 and 3. This cannot be the choice. So this is going to be the answer. All right. And obviously, since at the moment we are not giving any T, I'm there to explain the concepts. So let's find the value of A. Right. Now, when we talk about A, we can see that we have minus AX. So we need to look at the coefficient of x. This is x. The coefficient of x is minus 4. But we already have minus here. So this means that A would be 4 only. Okay. And then if we talk about B, that is the constant term. So the constant term on right hand side is 5. So B is 5. So 2 minus 3, 4 and 5. C is the choice, right? Okay. Now we have the fourth question. An equation in which two algebraic expressions are equal for particular values of the variable is called. Okay, now this is what you guys have been doing, right? For example, if we have 4x equals, let's say, 2x plus 1. Now here we have two algebraic equations which are equal for particular values of x. They are equal only for some specific values which we can find by making x the subject and then finding the value the way we solve equations. So this is what you guys have been doing. And I told you already it cannot be an identity because the left hand side and right hand sides are not identical. Yes, it is an equation, but we have a specific name for this type of an equation, which is conditional equation. Whenever two algebraic expressions are equal for particular values of the variable, this is called conditional equation, right? And obviously it is not a fraction and it is an equation, but we call it conditional equation particularly. It is a definition, right? Then we have rational fractions or partial fractions are of two types, three types, four types, or one type. Now we know that the very first thing which we have discussed in this lecture is we have two types of partial or rational fractions, improper and proper. So A is the answer. Okay. Now let's talk about the sixth question. This 2x minus 5 divided by x square plus 4 is dash rational fraction. Now either it is going to be a proper rational fraction or improper rational fraction. So let's just cut these two options. Let's look at the degree of numerator. We have x to the 1. So degree of numerator is 1. And in the denominator we have x square. So this means that degree of denominator is 2. Since 1 is less than 2, since degree of the numerator is less than the degree of denominator, this means that it is a proper fraction, right? This is what we discussed in the very beginning. So it is a proper fraction. Okay. Then we have the seventh question. If 7x plus 25 divided by x plus 3 into x plus 4 is this plus this, then find the values of a and b. Again, for finding the values of a and b, we need to make comparisons. But in order to make comparisons, we need to have same denominators, right? Here we have product of these two, and here we have two separate fractions. So we have to take LCM on the left hand side. Let's just do that. We have 7x plus 25 divided by x plus 3 into x plus 4. This is equal to this. So as I said, we'll be taking LCM. When we take LCM, the denominators would be same. So we have x plus 3 and x plus 4. And the numerator, obviously, when we take LCM, we have to multiply x plus 4 with this factor to get this denominator. So we multiply the same thing with numerator, that is x plus 4 with a. And when we talk about this x plus 4, we need to multiply x plus 3 just so we have this. So we multiply x plus 3 with b as well. So this is what we get. Okay. And now our denominators are same, so we can directly make comparison of the numerator in order to find the value of a and b. Okay. Let's do a further step. we have 7x plus 25 equals a into x and 4, right? So this would be ax plus 4a plus again b into x would give us bx plus 3b. Now we can make comparison, okay? Our denominators are same, so we can ignore them. We just have to make comparisons of numerators. So finally, we have the expanded version of right hand side. And now we have to find the values of a and b. So this is x. The coefficient of x on left hand side is 7. So the coefficient of x on right hand side is a and b. Okay, and when we talk about the constant term, so we write down x to the 0 because this is 1, this is the constant term. We can assume that we have x to the 0 here because it is 1, right? So the constant term is 25 on the left hand side, and on the right hand side constant terms are 4a and 3b. Okay, now this thing is very simple. We are interested in finding out the values of a and b. We have two equations. We can solve these two equations simultaneously and get our values. So we have 7a plus b, and the other one is 25 equals 4a plus 3b. Okay, so a can be 7 minus b. I can use this a in the second equation right here. This is going to give me 4 into 7 minus b plus 3b. So this is 25 equals 28 minus 4b plus 3b. And finally, if we take this 28 over there, we will get minus 3 equals minus 4b plus 3b minus b. So this is b equals 3. Now, if we use this value of b in this equation instead, we will get a equals 7 minus 3. This means a is 4. So a is 4 and b is 3. A is 4 and b is 3. Okay, right. So I hope this is clear. Let's talk about the 8th question. Okay, the partial fraction of this is of the form, okay, whenever we are interested in finding out the form of partial fraction, we only need to focus on the denominators. Whenever we have this type of a term in denominator, x squared plus 1, for this we get ax plus b. Okay, whenever we have such kind of a quadratic expression in the denominator, in the numerator, we get ax plus b. And for x minus 1, things would be simple. We will get c over x minus 1. Okay, now this choice is basically the D choice right here. So clearly, A cannot be the answer because we have 2 here, and for this expression you don't have you don't have to write it 2 times. It's not a whole square, it's not an expression of that type. It simply is a quadratic equation or quadratic expression. Obviously it's not an equation. So for such expressions we do ax plus b in the numerator and simply x squared plus 1 in the denominator, right? So D is the answer. Okay. And if we talk about the 9th question, so we have these fractions and they're saying this is the partial fractions of, okay. Now we need to focus again on the denominator only, right? We have this, this. Forget about these 4s and this 2, okay? Only focus on the factors. So let's just write down the factors here. We have 1 minus x, we have 1 plus x, and we have 1 plus x square. Okay, so we know that this basically is 1 minus x square, and we have 1 plus x square, right? So clearly we can see that this type of a thing can be seen in C option, because if we open this, we are going to get 1 minus x square and 1 plus x square, because it is a square minus b square, okay, for b equals x square. So again, whenever you come across such a question where either you have your partial fractions and you need to find the main fraction, or you have the main fraction and you need to find the partial fractions, only focus on the denominator, particularly on the factors of denominator, right? Like here, I simply crossed out these 4s and 2s because they are just going to confuse me. And yes, another tip. Here we have this minus 1 here without any expression, without any factor in the denominator. This basically is telling us that initially the fraction was improper fraction. So we have improper fraction whenever the degree of numerator and denominator is either equal or the degree of numerator is greater than the degree of denominator, right? So here the degrees are same. Hence, initially, if we look at this that way, every option could have been the choice. But the next step is we have to look at the factors. So we had this. We need to write them together. We got this and we get the same expression from this factor right here. So this is why C is the choice. Okay. Then we have the 10th question. An improper rational fraction or an improper partial fraction can be reduced by division to, okay. Now, whenever we have an improper rational fraction, we use long division to get a proper fraction, right? So we not only get a proper rational fraction, but also a polynomial. So this is the answer, right? I'll give you a quick example from here. Just like this question right here, initially we had this, okay? But since it is improper, we need to use long division in order to make it proper. So we get this polynomial. It doesn't look like a polynomial because we only have the constant term, but it is a polynomial. And all the other fractions are proper fractions because the degree of numerator is 0 and the degree of denominator is 1 and 2 in this case, right? So since degree of numerator is less than the degree of denominator, it is a proper fraction. Okay. So this is why D is going to be the answer. Right, let's talk about the 11th question. The rational fraction P of x by Q of x is called a proper fraction if the degree of P of x is dash than the degree of Q of x. Proper is only when the degree of P of x is less than the degree of Q of x. So A would be the answer. Okay, and we have this question. X over 2x minus 3 is dash rational fraction. Now, obviously, either it would be proper or improper. So, degree of numerator is 1, degree of denominator is also 1. Since the degrees of numerator and denominator are equal, this implies that it is going to be an improper rational fraction, right? So, B is the answer. So we have discussed this very thing in the very beginning as well. Improper rational fractions, whenever the degree of p of x is equal to or greater than the degree of q of x, right? So in our example, the degrees were equal, hence it would be improper rational fraction. So in this video, we have discussed all these contents, some basic idea about partial fractions, and then we have practiced some NET sample questions which are related to this topic, that is partial fractions.